right. So in example 1, we start off with a factored quadratic. When it's in factored form, it's really easy to identify our roots. So I'm just going to do that quickly kind of on the left margin of the page. To find our roots, we start off by setting our equation equal to 0. So we have x plus 3 times x plus 4 equals 0. Whenever you have two things multiplied together that are equal to 0, you know that one of those factors has to be 0. That's the only way to get 0 when you multiply two things together, is if one of them is 0. So that lets us split this up into two possibilities. Either the first factor equals 0, or the second factor equals 0. And we don't know which one, and frankly, it doesn't matter. These two things are going to give us two different answers, and those two answers are our roots. So in that first example, or the first factor, we have x plus 3 equals 0. In order to solve that for x, we just subtract 3 from both sides. And when we do that, we end up with x equals -3. For the second factor, very similar. We just have to subtract 4 from both sides, and we end up with the root x equals -4. So our two roots are x equals -3 and x equals -4. But do you guys remember before break, we did a Kahoot together where we identified roots for factored quadratics? We noticed a pattern. So take a look back at our starting point. We had x plus 3 and x plus 4. And the roots we ended up with were x equals -3 and x equals -4. So that pattern emerges here. We can probably skip the handwritten work I just did in the margin of the page because we know that pattern. We know, for instance, that we're just going to end up subtracting 3 from both sides, so we're going to get a -3, which is just the opposite sign of what we started with. And same thing, we're going to end up with a -4, which is just the opposite sign of what we started with. So for our roots, we can probably just look at our factored form up at the top and kind of skip ahead and just instantly know our roots using that pattern, okay? So I'm trying to save you some time on these problems. The roots should hopefully be the quickest and easiest thing that we have to find. Okay, so that finishes out the roots, but we also have to find the vertex and the y-intercept, and that's where standard form comes in. So in order to convert our factored form into standard form, we need to remember what we talked about yesterday. The step to go from factored into standard is multiply the factors together. So we have to multiply x plus 3 times x plus 4. And the way we were doing that yesterday is by actually drawing a rectangle and putting our first factor, x plus 3, across the top, putting our second factor, x plus 4, down the side, and then we have to use multiplication to fill in the 4 individual boxes of this grid. So in our top left box, we take x times x. That gives us x squared. Top right, we take +3 times x. That'll give us a +3x. Bottom left, +4 times x. That'll give us a 4x. And bottom right, +3 times +4 gives us a +12. So we have to write this in standard form, which means we take these 4 pieces and we write y equals x squared plus 3x because it's positive, plus 4x because it's positive, and plus 12, again, because it's positive. And if any of your terms are like terms, you have to combine those together. So we have a 3x and a 4x. Those are like terms. We will add those together and get 7x. So this is our standard form. The whole reason we did this is because once you're in standard form, you can easily pick out A, B, and C. A is the number in front of the x squared. And if there is no number there, you can just write in a 1. B is the number in front of the x, so that would be 7, positive 7 specifically. And C is the number at the end, so our C is 12. So you find your A, you find your B, and you find your C. And from there, we can use those to find our y-intercept and our vertex. So if you forget how to find the y-intercept or how to find the vertex, then you need to flip back to Monday's page in the packet because it should be in your notes. The y-intercept is just 0, C. And since we know C is 12, we know our y-intercept is 0, 12. So I'm going to go over here to my answers and write 0, 12 in as my y-intercept. Now the vertex is a little trickier. For the vertex, we have a formula we have to use. The x value of the vertex is equal to negative b over 2a. And the b comes from this and the a comes from this, right? Our ABC. So I'm going to write this over here since I don't have much room on the right. I'm going to say for the vertex, the x value is equal to negative b over 2a. But in for b, we have to put 7. And in for a, we have to put 1. So we put parentheses around those when we plug them in. That's important. It's especially important when we're plugging in negative numbers, for instance, but that's not what we have in this example. So we have negative 7 on the top when we simplify that. And on the bottom, 2 times 1 simplifies to 2. And we can leave our answer like this. This is a perfectly fine answer. Negative 7/2, we can write it like that. But it's a lot harder, in my opinion, to think about where a fraction might be located on the graph. It's easier if we convert that into a decimal. So you can either do this in your head, or you can pull out your calculator and type in negative 7 divided by 2. Negative 7 divided by 2 is negative 3.5. So I'm going to convert this into a decimal. That is the x value of our vertex, negative 3.5. But we're not done because now we need to find the y value. So we already found our x value of our vertex, which is exactly what we use to find the y value of our vertex. So what we're going to do is we're going to take our equation again, which is x squared plus 7x plus 12. We're going to take our equation and we have to find the y value by plugging in the x value. And our x value is negative 3.5. So I'm going to color code mine so you can see exactly where I'm plugging it in. Instead of x squared, we'll have negative 3.5 squared. And then plus 7 times, instead of x, we'll have negative 3.5. And then plus 12. So here's really the part that you're going to be using calculators for today. Nobody wants to actually do this in your head, so we'll type this into a calculator. As you do that, be careful. Remember, you have to have the parentheses in the right place. If you have a negative number, you need to use the negative sign. But when you're subtracting something, you need to use the minus sign. So it's 2 different buttons that you need to remember which one is which. So be careful as you type all this in. Negative 3.5 squared plus 7 times negative 3.5 plus 12. Okay. What you should get is negative 0.25. That's what I got. So that's the y value of our vertex. And that's going to go right up here. And now the only thing left that we haven't done is draw our picture. So all we're going to do is we're going to use the 4 pieces of information we already know, and we're going to draw those on the graph. So let's start with the vertex. Our vertex is at negative 3.5. Let's see, negative 123.5, and then negative 0.25. So that'll be just below the line, right about there. So go left 3.5 and down about 1/4. That's one of our points. That's our vertex. The next point we know is the y-intercept. That's at 0,12, which unfortunately doesn't fit on this graph. It's just above it a little bit. 0,12 will be up 2 units from the top. And then we have our 2 roots. Our 2 roots are x equals -3 and x equals -4. So the roots are always along the x-axis. So x equals -3 will be right here, and x equals -4 will be just right here. So they're really close to our vertex. It's kind of hard to draw it on here because it's so tiny, but you can see the 2 separate roots and the vertex. A few things to keep in mind as you're drawing these is, remember, your vertex is always in the middle of your parabola, and the 2 sides have to be symmetrical. They have to be mirror images of each other. So your roots should always be equidistant from your vertex. Your vertex should always be right in the middle of your 2 roots. So that might help you make sure you're getting an accurate picture, and you can use that to kind of check yourself as you're drawing these. So try to get a pretty accurate parabola. I know it's kind of hard when these points are so small and so close together, but try to draw it as accurately as you can. And that's all we have to do for these. So the only part of this process that's new this week is converting into standard form. We already knew how to find the vertex. We already knew how to find the roots. We already knew how to find the y-intercept, and we already knew how to draw a graph. So the only new thing is the standard form part. So I'm hoping that this will be a good opportunity to review some of the skills we already know, as well as working on something a bit new. So I want to talk about one more thing before I set you loose on the examples. Take a look at the 3rd example on this page. The formula that we start out with is y equals parentheses x minus 2 parentheses squared. We haven't seen a parabola quite like this before. So what this is, if something is squared, that would be the same as multiplying it to itself twice, right? Squaring something, squaring x minus 2, is the same as taking x minus 2 times x minus 2. It's just written in a slightly different form. So this is a factored quadratic equation. It's a factored equation. It just so happens that our 2 factors happen to be the same. So you might want to write this out as 2 separate factors just to get a good visual of what this is. But then for the most part, all the steps that you're going to do on this problem will be exactly the same. And there is another one like that on this worksheet. So what I want you to do for the next, probably 20 minutes, is try to get through as many of these examples on your own as you can. Use your calculators, find your special points, draw your pictures, get as far as you can, and I'll be here to help you walk around, check your work, answer your questions as you're working on these. And then in the last, 15, 20 minutes of class or so, I'll work through some of these examples on the board so you can check your work and make sure that you got the right answers. Sound good? Oh, actually, yeah, this is for everybody. I forgot to mention it. We don't really have to do a table for these. I got these questions off of a thing where I pulled the images from another source, and they just so happen to have a table on there, but no, you don't need to fill out the table. That's a great question. Thank you. So let's take the vertexes off a bit. You got the right x value for your vertex, but when you plug it in, something goes wrong. I'm guessing, so this should be 16 minus 32 plus 9. Oh. Well, yeah. And so that's just gonna change this. Yep. Alright, thanks. Yeah, you're welcome. Oh, I was. That is actually right. Unfortunately, your graph's not really big enough to handle that. So just draw what you can. I sort of did mine like this. This should obviously be way down, like -25, but I just said, oh, okay. And Marcus, the problem you're working on, that vertex is way down low. You might just have to kind of fudge your picture a little bit. I just sort of do it like this, and okay, let's just go way down here. All right, students, you guys are doing awesome. We have about 15 minutes left of class, and so what I'd like to do with those 15 minutes is at least tell you guys the answers on these problems so you can check yourself. As I'm doing that, if anybody has any questions, like, whoa, wait a minute, why is that the case? I can kind of briefly go through the part of the problem that you have questions about. We won't have enough time for me to go through everything in detail, but I at least can answer some pointed questions if you guys are confused about where one of my answers came from. Our roots are going to be x equals 2 and x equals 3. That's because we just take the opposite of the two factors, right? Then we convert our formula into standard form. And when you do that, you should get y equals x squared minus 5x plus 6. Pay attention and make sure that you have the same signs that I have. X squared minus 5x plus 6. So that gives you a y-intercept of 0, 6 and a vertex of 2.5, negative 0.25. Now I'm going to try to do my best to draw this. So 2.5 will be right, 2.5, and then negative 0.25 is down just a little bit. So it's about there. Then we have the y-intercept of 0, 6 and roots of 2 and 3, which are really close to that vertex. So do your best to draw these. It's not going to be super easy since they're so close together. Just try to get it as good as you can. So my parabola looks something like that. Remember, it needs to be symmetrical on the left and the right, so you can kind of use that to help guide yourself. All right, now let's do the same thing for the third problem. On the third problem, I gave you a little hint at the start. When you start off with something written as a square, so like x minus 2 squared, it might be helpful to expand it out. Anything squared is just multiplied to itself. So we could rewrite this as x minus 2 times x minus 2. So when we go to find our roots, we're looking at the opposite of the factors we started out with. And since we started out with negative 2 and negative 2, our roots are going to be positive 2 and positive 2. But it's a little silly to write the same answer twice. So all we really have to say on this for our roots is that our root is at x equals 2. We don't have to list it twice. Now we need to convert it into standard form in order to find the vertex and the y-intercept. So our standard form, after you draw your rectangle and do all your multiplication, you're going to get x squared minus 4x plus 4. So double check your signs. Make sure you got the same thing I did. And that means our A, our B, and our C are 1, -4, and 4. And that helps us find our y-intercept, which is 0, 4. And our vertex is -b over 2a, so that'll be 2. And then we plug that 2 back into the equation, and that gives us our y value, which is 0. So double check yours. Does anybody have any questions about these? Did you get them wrong and you're wondering why? All right, so we can draw this now. Now this is actually probably the trickiest one to draw, and here's why. Our first point, our vertex, is at 2, 0, which is just 2 spaces to the right. Our second point is the y-intercept, that's 0, 4. But then our third point is at x equals 2, which is the same as the vertex. We already have that point on there. So we really only got 2 points from all the information. This vertex is also our root, and it's our only root. So we don't have any other information we can use to draw this parabola, except, remember, parabolas are symmetrical. They're the same on both sides. And since we know that this is the vertex right here, we know that the parabolas have to be the same on both sides of the vertex. That means we'll have another point right here, because that's just directly opposite of the y-intercept. So we can use that to help guide our parabola. So it should look something like this. Any questions about this one? The hardest part of this example was probably drawing the picture based on so little information. So kudos if you got that one right. If you flip the page over, our next example starts us off with y equals x plus 2 times x plus 4. This is factored, so we can pull our roots out of it pretty easily. Our roots will just be x equals -2 and x equals -4. Then we should convert this into standard form in order to find our vertex and our y-intercept. Standard form will be y equals x squared plus 6x plus 8. And since our c value is 8, our y-intercept is 0, 8. Our vertex comes from -b over 2a, so we'll have to find our b, find our a, plug those in. We end up with -3. Then to find the y value, we put -3 back in our equation, and that'll give us the y value of the vertex, which is -1. Let's draw what we can. Our vertex is -3, -1. It's about right here. Our y-intercept is 0, 8. It's all the way up here. And our roots are at -2 and -4. So this is the information we have about our parabola. We could use the fact that it's symmetrical to find one more point over here at -6, 8, because it has to be exactly the opposite of the y-intercept. And draw your parabola. And voila. Okay, we've got plenty of time to get through the next 2 examples. Does anybody have any questions? Some of you might not have gotten to this example yet, and that's okay. Make sure you at least write the answers down. That way, if you decide you want to work on these later in the week for some extra practice, you can at least check your answers. Okay, for our next example, we start off with y equals x minus 9 times x plus 1. our roots are going to be the opposites of those numbers. So x equals positive 9 and x equals negative 1. Those are our two roots. Now let's convert this into standard form. You would use your rectangle and do all your multiplication, and you should end up with y equals x squared minus 8x minus 9. Watch out for those negative signs. Those will trip you up if you're not paying super close attention to those. So our A is 1, our B is negative 8, and our C is negative 9. We're going to use those first to find the y-intercept. Our y-intercept is 0, negative 9. That just comes from our C value. And the vertex is negative B over 2A. So that's negative 8, which will be positive 8, over 2A, 2 times 1. So we get positive 4. And then to find the y value of our vertex, you take that positive 4, you plug it back into your equation, and that will give you the y value. And our y value is pretty ridiculous here. 4, negative 25. I didn't vet these questions, so this one just so doesn't happen to really fit on our graph. We'll do our best to draw this, but let's start with a point other than the vertex. Let's start with the y-intercept. 0, negative 9. And then we also have our roots are at positive 9 and negative 1. So our two roots go here and here. And based on symmetry, we can figure out that we'd have another point here. So basically our parabola is going down like this. And it's going to go down really far, right? It's going to go all the way down to negative 25. But we can't really fit that on here. So I'm just going to kind of draw a little dotted line to indicate that, yeah, it does go down here and it loops around somewhere, but we don't have enough space to draw it. So sorry about this problem that it doesn't really fit on here. That's about the best we can draw. All right, one more. And this one is another square. Notice how we start. We start out with x plus 3 squared, which is the same as x plus 3 times x plus 3. So this one's going to give us the same root twice. It'll give us x equals negative 3 twice. We only need to write it once, though. So then let's convert our quadratic equation into standard form using our rectangle. When we do that, we get y equals x squared plus 6x plus 9. And then we now know our A, our B, and our C, so we can pretty easily find our y-intercept, 0, 9. And our vertex will be negative 6 over 2 times 1, negative B over 2A, which would give us negative 3. Then we take negative 3, we plug it back into our equation to get our y value, and we see that our y value is 0. Time to draw. We only have 3 points to draw this time. Oop, nope, I lied. We only have 2. So we start with negative 3, 0. And then we have the point 0, 9. And the only other piece of information we have is that x is equal to negative 3 is one of our roots, but we already have that marked. That's here. So we have the same dilemma in this problem that we had a few problems ago, where we only have 2 points to go off of. So we're going to have to be creative with how we decide to draw this. The vertex is the point I just indicated with that arrow. So we know that that's the exact middle of the parabola and that the two sides must be mirror images of each other. So we can use the other point, which we know is 3 units away, to find, so we can use the point on the right to find the point on the left. It's 3 units away, 9 units in the air, so we can go the other direction 3 units and up 9 to find the other point. And then those just kind of go down to our vertex, and there's our parabola. So I know that I didn't write out all the steps on these, but you guys were doing so great on these examples on your own. I don't feel like you needed me to write out all the steps. You guys were crushing this. So use the work that I just put up on the board to kind of check yourself, check your answers. But if you did not do every single example, that is absolutely fine. When I grade these at the end of the week, I'm just going to look to make sure you at least did a few of them today in class. You don't need to worry about finishing these on your own unless you want to for some extra practice.